The Raptor engine being developed by SpaceX may be one of the most important pieces of technology in humanity's quest to conquer the stars. The Raptor engine is made specifically to power both the Starship and its booster stage rocket, the Super Heavy. While the Raptor engine has been performing really well in both static fire tests as well as on the Starship itself, SpaceX is already working on the Raptor 2 engine that will be the refined and improved successor to the first Raptor engine. SpaceX has been secretive about the development of the Raptor 2 engine so far, but recently, SpaceX CEO Elon Musk revealed in a tweet that the new Raptor 2 engine was just test-fired for the first. Testing the Raptor 2. Elon Musk in a tweet revealed that SpaceX recently conducted the first-ever test of the new Raptor 2 engine. According to Elon Musk, they test-fired the Raptor engine to 321 bar of pressure before it exploded into pieces. He tweeted, "Got to 321 bar before RUD, but cause may be due to oxygen inlet pressure too low rather than engine issues." RUD stands for Rapid Unscheduled Disassembly and is a colloquial term used by rocket engineers to say something exploded. This is the first ever test of the Raptor 2 engine. In a static fire test, the rocket engine is firmly attached to a launch mount. During the test, the rocket engine is fired at full thrust. The purpose of this test is to see how the rocket engine performs. Rocket engineers are looking at everything from the plumbing of the rocket engine to see how much chamber pressure it can achieve. According to Elon, Raptor 2 was able to pressure 321 bars of pressure before it exploded, which kind of makes the Raptor 2 prototype engine the most powerful engine of its kind to ever be tested. The title was short-lived as the rocket engine did explode on the test mount. But it is important to note that this is just a normal phase of rocket engine development. In fact, that is the purpose of these kind of live fire tests, to see what are the things that can go wrong, so that they can be fixed on time. In the tweet, Elon Musk does say that the cause of the explosion could be due to the fact that the inlet pressure for oxygen was too low rather than any critical engine issues. But again, it's not all that surprising that the first Raptor 2 prototype engine exploded as SpaceX pushed it to 107% of its maximum rated thrust and main chamber pressure limits. However, we should point out that the first ever static fire test of the Raptor 1 engine was more successful, as it didn't end with the prototype engine rapidly disassembling unscheduled. How does the Raptor 2 compare against the first generation of Raptor engines? Obviously, the Raptor 2 engine will be miles better than the Raptor 1 engine. According to SpaceX, a Super Heavy booster stage rocket powered by a Raptor 2 engine will produce 50% more thrust than the next most powerful rocket ever flown. When asked about how much thrust was produced in the test, Elon Musk explained by tweeting back, "Raptor 2 has a larger throat diameter, so thrust is approximately 245 tons at 321 bar. This is considerably more thrust than the Raptor 1 engine, as the Raptor 1 engine can produce about 185 tons of thrust at chamber pressures of about 270 bar. Moreover, this thrust also beats the engine being developed by SpaceX's main competition, Blue Origin. The Blue Origin's BE-4 engine is designed to produce up to 244 tons of thrust force, and Blue Origin expects the thrust to be actually around 230 tons in flight. To Blue Origin's credit, the BE-4 engine didn't blow up on its first static fire test. According to Elon, the Raptor 2 engine will have much cleaner plumbing, wire harnesses, and a wider combustion chamber throat. This will allow the engine to produce more thrust in roughly the same package at the cost of a slight efficiency loss. Over the last 2 years, the CEO has mentioned the possibility of a power-optimized Raptor variant with up to 300 tons of thrust. But in the past few months, Musk says SpaceX has decided to keep the Raptor family as streamlined as possible. SpaceX has opted for just 2 variants, one with a sea-level nozzle that is the Raptor Center and Boost, and one with a larger vacuum-optimized nozzle that is Raptor Vacuum or RVac. To be fair to the Raptor 1 engine, SpaceX has technically been able to push it very far without failure. According to Elon Musk, they were able to push a Raptor 1 engine to 330 bars of pressure, and the Raptor 1 engine spent about 10 seconds at chamber pressures above 320 bar without failure during a stress test in August last year. If SpaceX had been able to get Raptor 2 engine to 330 bars, it would have produced around 252 tons of thrust force. That is about 12% more than what the Raptor 1 engine produced during this test. This is because the Raptor 2 engine has a larger throat diameter. What do we know so far about SpaceX's new Raptor engine factory? According to Elon Musk, a new Raptor engine factory will be built near the McGregor engine testing facility. This plant will specifically produce Raptor 2 engines optimized for firing at sea level, most of which will be used on Super Heavy boosters. Once operational, the McGregor rocket facility would be making 2 to 4 rocket engines a day. That would make the McGregor rocket facility the highest output rocket factory ever built. 2 to 4 rocket engines a day may not seem like much, but in the world of rocket science, that is a lot of engines being made in a very short period of time. Current Raptor engines are currently being built at SpaceX's main factory in Hawthorne, California, then transported to McGregor for testing. Flight units meant for the Starship program are currently tested at McGregor before being driven to the Starbase launch facility in Boca Chica, Texas. But once operational, most Raptor engines will be built at the McGregor factory. SpaceX has clarified that the Raptor vacuum will still be made at the Hawthorne facility in California. The McGregor testing facility has been SpaceX's home for testing rockets ever since SpaceX was founded. SpaceX leased the facility from the city of McGregor and started operations there in 2003, a year after SpaceX was established in 2002. McGregor has an explosive history. The McGregor testing facility was originally the location of the Bluebonnet Ordnance Plant. It was used in World War II to make bombs. After the war, parts of the facility were used to make housewares until Phillips Petroleum came along, starting JATO bottle and ammonium nitrate production. Later, Rocketdyne and Hercules Corporation would use the premises to make propellant for Sidewinders and other missiles. SpaceX tested their first ever engine, the Merlin 1A, at the McGregor back in 2003, after the 1A model was used for the first 2 Falcon 1 launches starting in 2006. SpaceX turned their attention to the improved Merlin 1C and then the 1D for the Falcon 9 V1.1. The McGregor facility has expanded over the years, getting things like a large test stand known as the tripod for Falcon 9 first stage test firings, as well as other testing infrastructure such as a stand to test second stages. Now, as SpaceX plans to expand the facility to make large-scale Raptor production possible, new infrastructure is being added to the facility. It now has a new test stand for Raptor engines that will allow up to 1 test firing per day, possibly up to 2 per day of the sea-level engines, the same type of engine used on the Super Heavy booster, as well as the center engines on the Starship. Construction of the new vertical stand was started in January and finished in May before an initial 15-second test firing. The Raptor test firings have been continuing, with both the sea-level and vacuum Raptors involved. The vacuum Raptors have been seen in the horizontal test stand, while the sea-level engines have recently been using both the horizontal stands and the new vertical stand. While the first ever test of the Raptor 2 engine ended in disaster, it's just part of the development process. And we expect to hear more about the Raptor 2 engine from Elon Musk and SpaceX.